There are certain properties of trig functions in which you don't even need to use your unit circle or a graphing calculator in order to figure out your sine, cosine, and tangent. So we're looking at basic identities of trig functions. Okay, so probably the most well-known identity that you will be using throughout pre-calculus as well as calculus will be the Pythagorean identity, in which cosine squared of theta plus sine squared of theta equals 1. And that is based on our unit circle, in which, remember when we were talking about the unit circle and finding the sine and the cosine, that those values were based on our triangle in which we had a hypotenuse, an opposite, and an adjacent. It's the same type of concept where we have a squared plus b squared equals c squared. It is the same thing. Our x value we know, and our y values can be represented with our cosine and our sine. And then our c is our hypotenuse. Well, if we're using the unit circle, we know that our hypotenuse is 1. So that's why it equals 1. And that's kind of the basis there for our unit circle. And here's how this is going to help. They may give you a value that cosine theta equals -4/5. What is the sine of theta? Okay, and this is where you could, without even using a graphing calculator or not even using the unit circle, you could set this up in order to find your sine of theta using this Pythagorean identity here. So I'd have -4/5 squared plus our sine value squared equals 1. Well, I've got 16/25 plus sine squared yet again equals 1. So it's basically like my Pythagorean identity. It's just I have a sine and a cosine there, and it really didn't affect anything. So I'm going to subtract. So I've got sine squared of theta equals 9/25. So I take the square root. My sine of theta equals 3/5. Now, when you're looking at this, you might not know whether it's a positive or negative 3/5, but at least it's a starting point. Okay. Like I said, it plus or minus, but it's the starting point. We also have some different properties in which we're talking about opposites, supplements, as well as complements and half turns. And these are all based on the unit circle in which I'm turning about the circle at X amount of degrees. So cosine of negative theta equals a regular cosine theta. Sine of negative theta equals negative sine theta. Tangent of negative theta equals negative tangent of theta. Again, I'm just going to go through these theorems. They will be asking you to apply them. Supplements, we've got sine pi minus theta. So we know that a half circle is dealing with pi. And so that kind of gives us an idea of why we've got that pi minus theta. It's because we're looking at the full circle. And then if you notice here, it's similar to our opposites, but not quite. So you could look at it as 180 minus our theta value. Again, what they're going to be doing is they're going to be asking you to apply these different values, and they're going to say, find the sine of theta when your degree is pi minus some value. And you just plug it in and go about your routine here. Complements. Oh, going back here. Supplements. If you think back on geometry, we know that a supplementary angle had to add up to 180. So it's the same concept of why we're using pi. So when we're talking about complements here, we're looking at that 90 degrees. But if we're talking in radians, that's pi over 2. We don't have a tangent value for this because at 90 degrees, our tangent value is actually undefined. So that's why we can't have anything. And that's just saying those two values need to add up to each other. If you think about it, if we're looking at our half circle here, our cosine and our sine have to add up to our pi over 2 in order to make our right triangle. Half turn. So half turn is when we're adding, where our supplements we're subtracting. So it's a half turn cosine of pi plus theta equals the negative cosine of theta. And the sine of pi plus theta equals negative sine of theta. And finally, last but not least, tangent of pi plus theta equals tangent theta. Okay, so I'm going to show you an example of what I mean by we're going to be using and how to apply these. So for instance, if I were to say that tangent of theta equals k, find the value when I've got tangent of pi minus theta. So I'm going to be looking at my supplements theorem. And that's because I've got that pi minus theta. That's how I know it corresponds to that one. Okay, so when I'm looking at this, I don't really need to look at the pi minus theta part. I'm not actually going to put that k value in there. I know, based on this, this is supposed to equal the negative tangent of theta. Well, if tangent theta is k, then I know that my value is just negative k. And all I did was I looked at the left side in order to figure out what the right side should be. And that was based on this theorem here of my supplements. Then I plugged in my value. Okay, so let's look at another example here. Let's say that I have cosine of theta equals k, and I want to find the value of sine pi over 2 minus theta. Okay, so again, I'm going back and I'm looking to figure out which one this matches up with. This is the complements because I've got that pi over 2. And I know based on my complements that the sine of pi over 2 minus theta in any instance is going to be cosine of theta. Well, what was my cosine of theta? My cosine of theta was just k. So that's all I need to do. They will give you some initial trig value, whether it's a k or whether it's a specific number, in which you can use your theorems in order to simplify it.